In this video, we're going to find the value of a so that the limit as x approaches 2 of 3x squared plus ax plus a plus 3 divided by x squared minus x minus 2 exists. Before we actually solve the problem, let's try a value of a given value of a. Say a equals to 1. Then 3x squared plus ax plus a plus 3 becomes 3x squared plus a is 1, so we just have x, and then a is 1 plus 3, 1 plus 3 is 4. So the numerator becomes 3x squared plus x plus 4, and then our limit becomes limit as x approaches 2, 3x squared plus x plus 4 divided by x squared minus x minus 2. Let's plug in 2 for x. The numerator is 2 squared, that's 4 times 3, 12, plus 2 plus 4, that's 18. And the denominator of 4 minus 2 minus 2, which is 0. So we have a ratio of 18 over 0. That, of course, is undefined. The limit does not exist when a equals to 1. We can try various values of a, do trial and error, but that, of course, there's no guarantee we actually are going to find a, and that's not the way to solve problems. We have to be systematic problem solvers that will result in a solution fairly quickly as opposed to trying many things. So we're going to look at the denominator first. The denominator is x squared minus x minus 2, and this approaches 0 as we just saw as x approaches 2. The only way the limit is going to exist if the numerator also approaches 0, then we would have an indeterminate form of 0 over 0, and we can eliminate the source of 0 over 0, try to find a limit of the remaining part. So let's bring back the numerator. It is 3x squared plus ax plus a plus 3, and as x approaches 2, so the limit as x approaches 2 of the numerator is 12 plus 2a plus 3, which we can write as 15 plus 3a. And we're going to set this equal to 0 and then solve for a. So 3a becomes minus 15. Therefore, a equals minus 5. This is the only value that a could be so that the limit will exist. So then 3x squared plus ax plus a plus 3 becomes 3x squared minus 5x, and then plus a negative 5 plus 3 becomes minus 2. This is the numerator that will have a limit that does not go to non-zero over 0, becomes 0 over 0. So let's look at the expression. Limit x goes to 2, 3x squared minus 5x minus 2 divided by x squared minus x minus 2. Plugging in 2 for x in both of these, we see that we have 0 over 0, that it's an indeterminate form. So we're going to factor both the numerator and denominator. We know that one of the factors is going to be x minus 2, so in the numerator this is x minus 2, and then what's left is 3x plus 1. You can check that when we multiply x minus 2 by 3x plus 1, we end up with 3x squared minus 5x minus 2. The denominator is x minus 2 times x plus 1. So here's the source of 0 over 0, x minus 2 over x minus 2. We can now safely plug in 2 for x and what remains, so we end up with 6 plus 1, 7 in the numerator, and then divided by 2. The answer is 7/2. So go back to the original problem. The question was, for what value of a does the limit as x approaches 2 of 3x squared plus ax plus a plus 3 divided by x squared minus x minus 2 exists? The answer is a equals minus 5. And what will that limit be? The limit as x approaches 2 of the resulting quotient, as you just saw, is going to be 7/2. For any other value of a, we'll end up with a non-zero over 0, which will either go to infinity or minus infinity depending on how we approach 2 from the left or from the right, and the limit is not going to